Xu to give us a systematic view of a hydrogen fuel cell. Ever since that the Spanish inventor identified platinum, so back in the 17th or something, we have been known it for about 250 years. But as technology is improving, it turns out that PGM can be used in miraculous areas. So they have a lot of a rosy picture for the future. Without further ado, let's welcome Anglo-American, so head of the expansion business development department of Asia Pacific for the PGM, Chen, to talk about technology innovation blazing the new trail for the PGM. Let's welcome Chen. Well, I feel super pleased to be able to be part of the second Shanghai Platinum Week program. So it's glad to see you again. Well, this is an opportunity for us to have some collaboration discussion about what's the future for PGM. I chose a very special topic for here today because everyone seems to have some understanding about PGM. Most of you have purchased some jewelry, right? And if you use industrial settings, there will be a lot of PGM used for chemical analysis. But also the auto catalyst is also the widest application area for PGM as well. Well, but as a matter of fact, today, the topic we're going to discuss is about how we can use technology innovation to maximize the relevance and the unique attributes of PGM to make sure that for human society, we can make a bigger contribution. So today, we are going to talk about science and technology innovation to blaze the new trail for new application areas of PGM. So I'm going to talk about 5 different areas for today's presentation. Well, to begin with, we're for sure going to talk about the resources distribution of PGM. This is something high on your agenda. You're worried about whether we have sufficient resources of PGM to be used for future usage. You can say, well, that's important. It's very relevant. It makes a difference. But do we have enough of it? So I'm going to shed some light on that as well. And also in the supply chain, what about China's position in PGM? Secondly, we do care about for the PGM, what about some of the latest technology innovation improvements? We're very happy to be actually provided by our partner from Shanghai to give us a report to understand what about the patents in terms of the patent filing and the technology transfer. What's the data for that compared with carbon and the silicon? So we can do some comparative study of that to understand that for the PGM. So what are the remaining value from that of which we can draw upon it and extract from? Second one is a double carbon target, which is a very important strategy for the future development for China. We have already become mindful of the fact that for the PGM, so its value and role in making sure China will achieve with double carbon targets, but we didn't have enough understanding of it. So I would appreciate this opportunity to give you a comprehensive view of the PGM and how can it assist China in achieving the double carbon targets. What's its role? What's its position? And fourthly, how can we blaze the trail for application areas? How can we let technology play its role? So what about new borders? What are they and where are they? So this is something I do want to share with you. Last but not least, we talk about science and technology innovation. That's for sure is about the platform for science and technology innovation. In this morning, from the Lingang group, so Mr. Yuan had done a very excellent kickoff remarks. About 3 years ago, on the 2nd of September, in Lingang area, we established Shanghai Lingang PGM, new International Trade and Science and Technology Innovation Center. So think about the information about the center will be briefed upon everyone because in the new innovation center, there are 4 different functions of that. Part of that is a very important one. In Shanghai, we want to establish the PGM application Technology Research Institute will be set up as Anglo-American. We are very pleased to be joining hands with the Shanghai Lingang Group to sign up strategic agreement. So as a result of that, for the application development of the PGM in technology research and innovation, we can take it ahead and move it forward. So together, we can do some work related to PGM on the Research Academy. So first of all, let's try to see the resource distribution. I believe that everyone knows this very well. So every year, the output for PGM, you really do take this issue seriously. But there's something we seem to be missing. What about the proven reserve of that? So proven reserve is more important than the annual output. So let's let the data tell the tale. So on the last column, it's about the reserves, and the one in the middle is about the 2 years output for palladium and platinum. So the left-hand side are the regions for production of PGM. Based on the geographical distribution, it turns out that it's not evenly distributed across the world because PGM is very limited from the data. South Africa is the biggest region with the biggest abundant endowment, and in terms of the reserves, South Africa is the biggest country. And this morning, several speakers mentioned that every year the output of a PGM, but from this perspective, the proven reserve is huge as far as I know. Say, for example, almost 69,000 tons. But you add up other different factors, I think it's about 100,000 tons or something amongst that level. But there's one thing. PGM is not something that's consumable and wasted and used and discarded. It could be recycled. So strictly speaking, we are using it for its time value instead of for its materialistic value because most of them can be recycled. So Mr. Bian, who is heading the CPMIC, is in charge of the recycling work. So think about actually the PGM material in that sense is very different from others in the sense of its time value. Now, I have mentioned that prior to me, speakers mentioned that China is the biggest consumer country of a PGM, about 30% or over 30%. I have done some categorization. So in the PGM, generally speaking, there are three different types of them for the PGM usage. First one is jewelry. So outside in our exhibition room, you can see a lot of well-done jewelry. Second one is the auto exhaust gas, and third one is industrial. So all different types of industries. Later on, if I have some time, I'm going to shed some light for different industries as well. So from this one, in the three major application areas, I think the proportion is very surprising. Jewelry 41%, industrial is about 41% together in auto. So the exhaust gas, the catalyst, 37%. That is to say, PGM in China's economic growth is playing a pivotal role. That's exactly why I think it's very necessary for us to sit down and think through how we can use the powers of science and technology innovation to make a difference for the PGM. Given the limited resource, we can maximize its role. For PGM, it's very special. In what way do you think it is special? I'm not expert in this area. So I have asked for the expert opinions about this one. So, but the message I'm trying to deliver is that from the atomic structure perspective, it has a very special atomic structure. So that's dependent on the special attributes of that. So for example, it's in line with the Hunt rule. And Hunt rule, what does that mean? You can Google for that. Or that is to say, diameter for its atom is very long, so it has a lot of different areas. Radio area has a very strong absorption capability. And second one is that there's stability for electron trajectory. It can provide a lot of a spare room for absorb the electrons. As a result of that, this is about the catalytic. So from scientific perspective, it's reducing its activity on the right-hand side. So the third column is talking about it. So just because of it, you'll find that so it's kind of a very erosion preventative, so resistant against the corrosion across all different metals. It has the most strongest attribute for corrosion prevention. On the right-hand side, there are some analysis about this chemical reaction for the PGM and also for the surface materials. What about the physical and the chemical reactions of PGM to make sure that they can reduce the activity power, to make sure that they can catalyze the reaction? Catalysts can do two things. The first one is a combination. The other one is degeneration. So, as I said before, we are very pleased to be supported by Shanghai Technology Exchange. They have given us a lot of report. So, think about the silicon is a very hotly debated issue, like semiconductor. So is carbon. What about PGM? So based on the data, you can tell. So no matter the number of patents, filings, and technology transfer, the scale and the volume compared with the carbon or the silicon, there is a huge difference between them. So here you can see that in the research of PGM, I think still is worth our continuous efforts. And of course, there are a lot of undiscovered potentials for us to mine. PGM. What's its contribution to carbon reduction? And what's the contribution from it towards China's achievement of double carbon targets, I'm going to give you an overview. When we talk about carbon emission and double carbon, it's safe to say that over 50% of the carbon emission will come from energy, right? Like power generation, especially fossil fuels. So think about the fossil fuels as a source for generating power. The second one is metallurgy, like a refinery of steels. And third one are industrial usages, like chemical production, like a company's production. And the fourth one is transportation. Think about all the top 4 ranking ones, the big sectors which will have a lot of carbon emissions, PGM, in the top 4 user scenarios can play a very important role. Let's first look at transportation. Madam Wang had already given us a very good introduction, right? So in energy, it's safe to say that in the future, recyclable, recoverable, green technologies like wind power, PV, hydropower, so those things in the future are for sure are going to serve as alternative towards fossil fuel-based power generation. And especially for PV and wind power, I think they have some requirement for energy storage. In the area of energy storage, so there are short-term, medium-term, and long-term and the seasonal energy storage system. Green, sustainable energy, maybe one day could be used as the alternative towards the fossil fuel when it comes to power generation.
是一些大宗的化学品。那么，如果这些大宗的化学品如果能够采用先进的铂族贵金属催化剂的话，大家可以看到，随着后面几年，它们所带来的碳减排的量有多少。
To raise your attention to, so PGM not only has a positive impact in reducing GHG emissions in some limited areas, but rather it will have a very positive impact on all 4 predominant areas, and is integral, by the way. So let's just go back to a hot topic today, that is to blaze the trail or to expand the boundary of PGM application. We need to keep expanding the boundary because PGM represents something that God endows us with, so we should not. We are obliged, we have the capability, and we are willing to use the technology to keep expanding the boundary of the application of PGM. By that, I have presented on this slide 10 different borders or areas. I wonder if you are familiar with any of them. I am sure you are familiar with some of them, but you may not be very familiar with pharmaceuticals or electronics, nor are you very familiar with energy storage that was introduced before. So next, I'm going to talk about what are the areas of interest, or what are the hot areas in R&D in these new boundaries. Firstly, agriculture. About 30 to 40% of fresh produce are wasted. They are either rotten on the ground or they are wasted, and they're rotten in the process of transportation or in the warehouse. Maybe if you're interested, you can do some search about why these fruits and vegetables, they become rotten, because they breathe. And the more they breathe, the quicker they age. When talking about breathing, the first thing coming to mind is carbon dioxide and oxygen, and vegetables and fruits, they generate something called ethylene, and ethylene is something that will accelerate the aging or the maturing process. For example, banana, when you purchase raw banana and if you add some ethylene, then they become mature more easily. For example, if you put bananas in rice container, then these bananas, they mature more easily. That's because ethylene is contained within, and the faster they mature, the faster they become rotten. So we see in the process of production, transportation, storage of vegetables and fruits, the temperature and the conditions control become something of great value. So some people are studying how to use PGM to control the storage condition, including the oxygen, carbon dioxide, and ethylene in preserving vegetables and fruits. By controlling such conditions, we can extend the shelf life of vegetables and fruits. So that's one area of focus in agriculture regarding using PGM. And the second area is something that you are very familiar with. It makes people who wear them beautiful, and it represents something of cultural value. If you're interested, you can go out to an exhibition store by us our association, and you will see some of the jewelries that we produce. I like them very much. I like the 3 words on these jewelry products. Firstly, be gentle, and second, be resilient, and thirdly, I think something if it combines resilience with gentleness, then it's just very good. However, there are a lot of difficulties using PGM to produce jewelry, so there are a lot of innovative points on this front. The first is material. In other words, the different components of the materials by adding cobalt or by adding magnesium or adding other chemical elements so that the production process becomes easier and they can fit different types of designs. Of course, there are other methodologies of making jewelry. For example, there is a new type of producing called 3D printing. So if we can successfully add 3D printing to the making of jewelry, we can truly achieve the design and making of unique jewelry products to express something that's unique to us, our unique feelings. So that's another area of focus for us regarding the application of PGM. Another area is clean emissions, something that you are very familiar with. And when talking about clean emissions, the first thing coming to mind is the vehicle. However, everything that's related to engine has the problem of emissions, including vessels as well as the vehicles that do not run on the road. Now they have more demanding or more stringent requirements with regard to emissions. For example, vessels that sail on the Huangpu River, they are not allowed to emit any black flume or a gas. Otherwise, they will not be allowed in to sail on the Huangpu River. So how to do clean emissions? There are ways to better produce these vessels using PGM, including increasing the efficiency of PGM in the process of production. Another area is chemical and catalyst, as was covered by me before, how we can use environmentally friendly and low carbon materials as an input point to produce chemical products. So here I would like to give you an example that you are already familiar with. For example, the coating technology. And do we do the same now? No, because there are more stringent requirements, environmentally speaking. So in the chemical industry, we currently have this requirement that we need to have green and low carbon methodology or pathway to replace the traditional one. Some of the pathways were invented, including MMA, in the 1930s. This is the raw materials that we use to produce organic glass. So the materials they use were invented back in the 1930s. In 1937, do you think people even thought about environmental requirements back then? I don't think that was the case. Another area is environmental protection. You are very familiar with this area. The biggest challenge here is disposal and treatment of VOC. VOC represent organic and volatile organic chemical thing. Electric vehicles that are growing by leaps and bounds have very important part or component in the battery called membrane, and the production process of membrane produces a lot of VOC that are hard to remove. A lot of people are working R&D on this front. How can we use platinum and palladium-based catalyst to do catalyst as well as oxidation to get rid of VOCs? So from this perspective, I think you also see yourself that PGMs can play a role in the electric vehicle industry, something that's very popular nowadays. That shows the huge promise and potential of PGMs. Another area is water treatment. We currently have sophisticated technologies in dealing with wastewater. However, there are highly polluted water from certain industries, including
printing, dyeing, and pharmaceuticals. So in those water as a result of the production from those sectors, we find that actually the VOC is very high. So it's highly polluting. Usually we use like incineration, but it's very expensive. Now, a lot of different research institutions or universities are trying to understand under low temperature context, how can we deal with the highly polluting wastewater by using the PGM as catalyst. So this is a very interesting research direction. Another one is like electronics. Maybe it's very hard for everyone to imagine that. So think about the OLED TV you are buying. So in the OLED, so think about the OLED materials. Now, actually there is iridium, part of the PGM there. So because you have the RGB, the three basic primary colors. If I remember correctly, I believe that the iridium has been used for red and yellow, and also but the green and blue has some problem in the sense that a lot of the research institutions are trying to develop like platinum, palladium based like the ones emitting the blue and green light, OLED. And in a chipset, so the PGM has a lot of relevant application as well. So think about for example, the hard disk and hard drive, they have the they have the PGM there. When we study chipset, so we are thinking about high performance chipset so that it can store bigger volume of data or something. But as a matter of fact, there is one permanent issue which is confusing to everyone. Think about the energy consumption of chipsets. If you don't bring down the chipset energy consumption, you cannot bring down the temperature. If the temperature cannot be cooled down, efficiency will not be high. So a lot of research institutions, they are trying to use the PGM as the point of departure to work out some of the energy efficient products. So think about compute versus storage could be combined together, integrate together with some institutions of China Academy of Sciences. So think about sensoring, storage, and also computing. 3-in-1 chipset could be developed. So that way it can increase the computing efficiency at the same time, bring down the power consumption of the system. This is going to be a very valuable and worthy endeavor. So maybe people don't know a lot about it, but that's a very important research area. The next one is even more excellent in the pharma industry. You have always known some medical devices, so like implantables using PGM, like cardiac devices, or the ones that can fit into your ears or something. But as a matter of fact, so in terms of anti-cancer, it has been used for a long term. So you find that the carboplatin has been used for the cancer treatment. Well, but it has some by effect and side effect as well. So that's why across multiple different occasions, we work with universities to do some joint research about the low side effect, more targeted solutions based on the platinum. The anti-cancer drug has been worked on for multiple years. So actually a lot of different countries are working on that as well. Some academicians, professors, and universities in China are working on that. One more interesting thing, I think is a very important direction. We call it IVD. So the IVD is very important for diagnosis of disease. We can use the PGM to develop the BAO chipset. So as a result of that, this is going to use a human fluid to do a very precise analysis and testing of what's the problem for you. Maybe you have the DNA testing, but the results are not as accurate as this one. So now a lot of different institutions, higher institutions are proactively studying that. Of course, power storage, energy storage. So hydrogen, as we mentioned, is an energy carrier. But for NEV, so you find that in terms of the PGM, to be fully used for the energy storage, it could find its more relevant ways. So PGM could work together with a nano carbon tube to make sure that in the future, actually the active materials in the lithium-ion battery could be used as well. At the same time, it could be used for electrolyte for the solid-state battery. So these are all the research areas of a lot of universities as well. And more interestingly, now there are ongoing research areas called the intelligent battery system. This is about how can we make sure that the sensor can be embedded into the inner parts of a cell. As a result of that, actually, so the pressure, gas diffusion, and electric current, temperature can be measured in a real-time fashion. So the embedded sensors to the battery is operating at the asset environment So we didn't see any other materials who could be acid resistant, because think about the battery environment. In the acid environment, you have to make sure that the materials will last for at least 10 years. So you'll find that actually it's some very stable sensoring capabilities is going to be used a lot. So I'm happy to see a lot of research over that area as well. Hydrogen has been mentioned. So in the making, storage, refilling, and transportation of hydrogen, PGM has played an important role. Now, let's think about the hydrogen generation. We have to use an innovative way to make sure that PGM can be introduced into more scenarios, just like, for example, making the hydrogen. So, for example, like an alkaline electrolyzer. Together with a lot of different companies in the market, we are trying to understand the alkaline electrolyzer. How can they use the PGM to reduce the cost of usage and extend its efficiency and trying to produce a cheaper hydrogen? So these are all very worthy research topics. There are some new materials as well. I'm not sure if anyone knows about the max materials. So this is like kind of artificial engineer manufacturing materials, which means that it's artificial. It's not existent in nature. So given this nature, how can we use a PGM and design it as a part and parcel of an integral part of a material? That's a very interesting thing. So we call it two-dimensional materials. So these are something which were not born with the nature. Instead, our scientists, based on what we need and based on different elements, they design it in a way to combine this new material. So PGM can play very positive and interesting role in that area for developing new materials. So I believe that these are the current research focus for new energies as well. And fluorescent materials is something I mentioned before. Okay, that's it. These are the 10 different borders or new territories we can enter into. Hopefully, that will be helpful for you to understand that in terms of the technology innovation capability, so there's a chance to make sure that it can play a unique role as well. So what we need is a research platform. We mentioned that the establishment of the PBMC. So think about the establishment of this center. So think about it. I think there are 4 parts of the PBMC. There is an industrial cluster. Second one is the industrial foundation. And then we have to prepare for the productive factor markets. And more importantly, we have to establish like the technology research institute for PBMC, so which is being worked on. Anglo American. It's our great privilege to work with the Lingang group to make sure that we are part of the member for this research institute. Think about the future of this research academy. There are going to be 4 different work areas. To begin with, our research academy needs to sponsor the scientific research, which is focusing on the PGM. So as I said before, in the 10 different areas, different scenarios, we have to sponsor research into those 10 areas, of which we are going to be very proactive in supporting them, of which we incentivize the research institutions, universities, and enterprises to conduct some innovative research centering around PGM, because right now there are like sporadic, fragmented resources in different research institutions, universities, or something. So that's the value of us. We are an integrated platform to sponsor and finance those sporadic efforts of research. We empower them so that they can proactively promote their research. The second role we can play is like evaluation. So we want to support our industrial foundation to do some evaluation, so some relevant projects about technology and its feasibility and also its future prospect as well. Thirdly, think about the Lingang Group. In Shanghai Free Trade Zone, we enjoy the benefit of the policy incentives and policy favorable terms. So we hope that we can help the Lingang Group to formulate some of the policies which will be conducive to PGM development so that the whole industry can be empowered. As a result of that, we can promote the PGM industry to prosper in Lingang area. And more importantly, we want to develop ourselves into a platform for international exchange and communication. Last but not least, there are 2 different directions we need to work on. The first one is a bottom up. The other one is from the top down. So from bottom up is back to the pillars we said about sponsoring and financing work, of which we're going to sponsor the PGM research and help them to achieve the commercialization. So this is called a bottom up approach. So what about the top down method, of which we're we're going to proactively get to understand from different industries of the 10 different areas. What about technical pain points of them? So when we get to know the technical pain points of different sectors, our research academy are going to put together the efforts of the researchers to get to understand and to think about, so is there anything that is based on the PGM? Is there a solution based on that? So as researchers, so they need to work with both legs to two things simultaneously. One is bottom up, the other one is top down. Okay, thank you very much for staying with me. Thank you for listening to my presentation. So hereby, I'd like to do like a commercial or something to give you a sneak preview. In about 2 days' time, in the same site, we're going to have the Science and Technology Innovation Forum, of which we are going to talk about the 10 different areas. So what's going on right now? What about ongoing cooperation? And we're going to let you know. And there will be 3 interesting topics to have some open-ended discussion on the 7th of September. If you have time, you can feel welcome to join our further session. Thank you.